Hello and welcome to the classes by Mrs. Monisha Nath Paul. We are back again with the topic congruence. We have already discussed the sums based on side angle side, side, angle side and angle side angle in my previous videos. Today we are going to go ahead with this chapter with more of the sums. If you haven't yet gone through the videos of the previous of this lesson, please go through the videos right from the very beginning, that is starting of the from the introduction or the starting of the lesson congruence. Each and every details have been mentioned in the previous videos. So the description box will have the links of the previous videos. Kindly go through them. Okay, you can see there's a sum already mentioned on the board. And what does it say? It says that BE and CF are two equal altitudes. Altitudes are perpendiculars. So BE and CF are two equal altitudes of a triangle ABC. We have to prove that the triangle ABC is isosceles. So this is the question. So how do we start? So right angle has been mentioned here. So right angle means the very first thing that comes in our mind when we see a right angle triangle, we think about the RHS axiom. But just thinking of the RHS axiom will not help, because in the previous video, if you go through, you will come across a right angle triangle, but the RHS axiom or the RHS rule was not used over there. We had used some other rule over there. So just by having an right angle does not imply the proof will be done by RHS. It may or it may not. So let's see here. So we have to prove that the triangle is isosceles. So for isosceles triangle, what are the conditions? That is, the two sides of the triangle will be equal and the base angles, that is the angles opposite to the equal sides, will be equal. Okay, so going by the definition, we have to come to the definition of isosceles triangle in order to prove an isosceles triangle. So let us see the question here. So this is the triangle. Here it is given to us that BE is equal to CF. All right, that much is given, and two perpendiculars is given. So if we take the triangles, in triangle BFC and triangle CEB. So talking about these two triangles, this triangle and this triangle. So both of them are having 90 degrees. Okay. Now, also if you see that they have a common hypotenuse, that means that is a common side to both the triangles. And also one of the remaining sides, that is here BE and here CF, is equal. So we can see that we can use RHS rule over here in order to establish the congruence of the two triangles. So first is, we can say angle BE's angle, this is BEC and CFB. So BEC and CFB, these are the two triangles. Okay. Okay, so you can see a problem on the board, that is BE and CF are two equal altitudes of triangle ABC. So there's a triangle ABC and BE and CF are two altitudes of the triangle. We have to prove that the triangle is an isosceles triangle. So what is an isosceles triangle? A triangle in which two of the sides are equal. So we have to prove that in this triangle, two sides are equal in order to prove the triangle to be an isosceles triangle. So when we see the figure, we can see two right angles here. So when we see right angles, the very first thing that comes in our mind of the rules is that the RHS rule. But please remember, for every right angle triangle, the RHS rule may not be used to prove the congruence. In the previous video itself, you will see that there was a sum which was a right angle triangle, but we did not use RHS over there. For RHS, it should, for RHS, all the three conditions, the R, the H and the S should be there. So it's not that only for right angle triangle you see in the question, it has to be proved via using your RHS rule. It's not like that. But let's see, check this sum out. So if we talk about these two triangles, that is triangle BEC and triangle CFB. So let us take these two triangle BEC and triangle CFB. So in these two triangles, we can see both are having 90 degrees. Okay, right angles are there. Then for the triangle BEC, BC is the hypotenuse, and for the triangle CFB, the hypotenuse is CB. So both the cases we see that is the same hypotenuse. It is a common side. Okay, hypotenuse also. So we got R, we got our H, and then you can see CF and BE. They are same. That is, out of the two remaining sides, one of the remaining sides are equal for both the triangles. That means the S is also obtained. That means we can say that that these two triangles can be proved using the RHS rule. So in triangle BEC, we can say angle BEC is equal to angle CFB. Why? Both are equal to 90 degree. What is the reason? Reason is BE is perpendicular to AC and CF is perpendicular to AB. So obviously for perpendiculars, the two angles are 90. That is, BE is perpendicular to AC, therefore BEC is 90 degree, and CF is perpendicular to AB, so CFB is 90 degree. Next we see the right angle part is done. Now next is BC equals to CB. Why BC is equal to CB? Because both have the hypotenuse BC. That's a common hypotenuse or common side for both the triangles. But I said BC is equal to CB because you see by the naming, by matching the vertices, BC for this means CB for this. So I said what? Try following the order of the vertices when you write about the triangles. So BC for BEC, if I say BC, then for CFB I will say it is CB, because B and C here corresponds to C and B here. But both refer to the same thing, because line segment BC and line segment CB refer to the same thing. So this is clear, I suppose. BC is equal to CB, and first one is also clear. Angle BEC is equal to angle CFB. Okay. Third is given to us already. What is it? That is BE equal to CF. You see the vertex are already there. BE, they're in the proper order of the vertices. BE, CF. And this is given. The two altitudes are equal. That is BE and CF. It is given to us that they are equal. So we can easily say over here that is triangle BEC is congruent to triangle CFB by RHS rule. So by RHS rule, we have established the congruency. So next what we can say about this is that for triangle BEC, the angle C equals to angle B. Okay, the triangle, for this triangle BEC, the angle C for this triangle and the angle B for this triangle is same. Now if we see, this is with CPCT. Now in triangle ABC, if angle C is equal to angle B, what does it imply? Angle C for a triangle, if two angles are same, suppose this is ABC, this triangle. So C is equal to B. That means AB will be equal to AC. What is the reason for this? Reason is sides opposite to equal angles are equal. Property of triangles. Okay, so AB is equal to AC. So in triangle ABC, we were dealing with these two triangles. Now using the CPCT part of this, that is angle C and angle B are same. From angle BEC, we have proved that angle C, and from angle CFB, we have proved that angle B, they are equal. Why? Because see, B and C, they are the corresponding angles, and for congruent triangles, the corresponding angles are equal. So angle C is equal to angle B, that is with CPCT. Okay. C and B. The angle C for this and angle B for this. Yes. So for BEC, the angle C, from BEC, the angle C, and for CFB, the angle B, they are equal. So angle C is equal to angle B. This is with CPCT. So now taking the whole triangle in the picture, so it is angle C equal to angle B. For the whole triangle, angle C equal to angle B, what does it imply? That is the sides opposite to equal angles. For this angle, this is the opposite side, and for this angle, this is the opposite side. So for angle C, AB is the opposite side. So C refers to angle B, opposite side, and AC refers to the opposite side of angle B. So these two are equal. That means, what is the reason? Sides opposite to equal angles are equal. So therefore, triangle ABC is isosceles. Hence proved. So the sum is being proved here with the RHS rule. I hope the sum is clear. Now we will be solving another sum in which I will give you some time to think about the rules that you will use in this sum. I will also show the solution to you, but I will give you some time to think about the solution. Coming to the next problem. In the given figure, AB is equal to CD. So AB and CD are equal, and angle ABC, this angle is equal to angle BCD. BCD is this angle. So these two angles are same, these two sides are same. We have to prove that AC equals to BD. So these two sides are same, we have to prove. So if you see the given sides and the arc sides, they are part of the triangles ABC and DCB. So we'll prove the congruency of these two. But do we have sufficient reasons or sufficient conditions to prove the congruency? We can see these two sides are same. This side, these two angles are same. And one more thing you can see, that the side BC is common to both the triangles. Which two triangles? Triangles ABC and triangles DCB. So we are going to prove the congruency of triangles ABC and triangle DCB. So in triangle ABC and triangle DCB. Okay. So very first thing that you will say, what is the rule we are using here? Side, angle and side. So AB equals to DC. It is given to you AB is equal to CD. So we can write CD as DC. I said always try following the vertices in the order. So AB is equal to DC. So AB is equal to DC. This is because AB equal to CD is given. Alright. Next we are coming to the next one, that is angle. So second, angle B equal to angle C. Why? It is given to you ABC equals to BCD. Angle ABC is equal to angle BCD. This is also is given to you. ABC, BCD. So we can say angle B and angle C are equal. Third, BC for this triangle will be equal to CB for the other triangle. Okay. So BC is equal to CB. So BC, corresponding side to BC is CB. So BC is equal to CB. This is common side. Alright. So three conditions have been placed here. See, side, angle, side. So in the order only I have placed, easier for you to understand. So therefore, triangle ABC congruent to triangle DCB by side, angle, side, rule. So with this, we can say that AC is equal to ACDB, that is CP CT, that is, going by the question, AC is equal to, this is asked, AC is equal to BD. Okay, I wrote you with the vertices corresponding sides, AC is equal to BB. After that, I changed it as per the question. So that is AB is equal to AC is equal to BD. So AC is equal to BD. That is your first part. That is done. This is proved. First part is proved. Now second part says we have to show that BE, E is this, BE is equal to CE. This is the part that you have to prove. But BE and CE are not parts of this triangle. So this is the part of this and this triangle. That is triangle ABE and triangle DCE. So I give you some time to think. This is one part of the problem. You have to prove this part. So for this we need another pair of triangles. So check out which rule you will use over here in order to prove the congruency. I'm giving you some time, think about it. Then we'll go ahead. So if we prove the congruency of this triangle and this triangle, what are the things we have in our hand? First is these two are vertically opposite angles, and we know vertical opposite angles are equal. Second, AB and DC are equal because it is given already in the question. What is the next one? Three conditions must be there about the for the establishing of your congruence. So what are the three things that you can prove? I mean, three things that you have so that you can prove. Some might have already guessed it. This angle and this angle is equal. Why? From here. From these two triangles ABC and DCB, we can say also angle A is equal to angle D. Same reason. CP, CT. Okay, now using this in the next part of the problem, that is in triangle AEB and triangle DEC. So first thing that you will say is angle A equals to angle D. What is the reason? Proved above. You have already proved it above. Okay, angle D A is equal to angle D. Next, okay, this we write in the second case. Why second case? Because angle side rule we will be using. So first we mention about this. So angle AEB equals to angle DEC. This is vertically opposite angles. Next, angle A is equal to angle D. This is proved above. I said follow the sequence in which you are trying to prove. So if you follow that, it will be easier for you to cross check your problem. Okay, so next is AB equals to DC. So see, if we have written it, AEB is equal to DEC, angle A and angle D, they are corresponding angles and they are equal. Here we have proved it above. And AB equals to DC. What is the reason? This is given, what was given to you, that is AB equal to CD was given to you already. So therefore we can say triangle AEB is congruent to triangle DEC by, see, first one angle, second one angle, third one side. So angle side rule. So what we have to prove? BE and CE. So you see BE and CE. BE, CE. They are corresponding paths. So BE and CE, they are equal, and the reason is so we have used two congruencies. The first congruency was proved. With the help of the first congruency, the second one was proved. So this is an example of a sum which will include two kinds of congruencies in the same sum. So I hope you have understood the sum clearly. Go through all the videos of this topic, students, from the very basic till whatever videos have been given to you based on this topic, and make sure you don't miss out any topic, because if you miss out any of the video, then the next video becomes difficult for you. So if you like the videos and like my way of teaching, please do like the channel, comment your doubts, your problems, so that I can help you out in solving them or guiding you out in the way to solve it out. Subscribe the channel, share the channel with your friends so that we can move ahead together. See you soon in my next video. Thank you.